Okay, let's look at some examples from the 6.2 homework. And we're actually going to start with number 1, the very first question. So this is a function. I've got a multivariable function that's in terms of both x and y. And I want to find the partial derivative in terms of x, the partial derivative in terms of y. F sub x, remember this is just the same thing as this, right? Just a partial derivative in terms of x. But this just means now I have numbers to plug in. And same thing over here. This is just the partial derivative in terms of y with numbers actually plugged in. So let's start with this partial derivative of z in terms of x, or f sub x. My derivative rules all still apply for multivariable functions, which means I can focus on each of these terms individually. So let's start by looking at that first term. This term depends on x. So what's my derivative of this term in terms of x? It's just my normal derivative. So 15x squared. There's nothing complicated about this term because it's completely just in terms of x. So it's like just taking the derivative of a normal one variable function. Okay, well, let's look at the next term. Negative y squared. Negative y squared does not depend on x. But this is still the partial in terms of x. So because that doesn't depend on x, but only x is changing, how is your output changing for this term? It's not changing at all. I'm treating this as a constant, and the derivative of a constant is 0. Okay, last term, 7xy. This depends on both x and y. But remember, for the partial derivative in terms of x, I'm going to treat this y as a constant. In fact, it might be helpful to rewrite this, putting the y in front. Why? It's easier now for me to treat that as a constant. 7, since y is being treated as a constant, I'm going to lump it with my 7, because that's what 7 is. 7 is a constant. So what's my derivative of a constant times x? The x goes away, and you're just left with a constant. And so I'm left with just the 7y. And there's my partial derivative in terms of x. Let's do my other partial derivative. So now let's go through this again. Start with that first term. How does that function depend on y? Well, it's completely in terms of x. It doesn't depend on y at all. Therefore, we're going to treat it as a constant. What's the derivative of a constant? It's just 0. Okay, next term is completely in terms of y. So I can just take the derivative of this normally. And I get negative 18y to the first, or just negative 18y. Notice how I don't have to use implicit differentiation here. I don't have to multiply this by a dy over dx or anything because y doesn't depend on x. It's completely independent. Okay, last term. Same thing here, except now y is the variable and x is being considered constant. X is staying the same. So, similar to how I did it with the x term, I'm going to group x, my constant term, with the 7, which is also constant, and I'm going to treat that piece as constant. What's my derivative of a constant times my variable? You just keep the constant. So I'm left with plus 7x. And there's my partial in terms of y. Now I'm ready to actually plug things in. So f sub x of 5, negative 5, just means I'll plug in 5 for x and negative 5 for y. And I get 340. Okay, I'll do the same thing for my partial in terms of y. I'm going to plug in 5 for x and negative 5 for y. But now I'm using this equation. So I get negative 18 times y, which is negative 5, plus 7 times x, which is positive 5. And I get 125. Okay, so this was just a great example of how do you take these partial derivatives? How do you actually treat the other variable as a constant? How does that affect your derivative? Okay, the next one I wanted to go through is number 4 from your homework. And this one, I wanted to do this one because this one's pretty tricky. All this one is asking for is the partial in terms of x and the partial derivative in terms of y. Let's start with that partial derivative in terms of x. That means, once again, what does that mean? That means I'm going to treat y as a constant. Well, I see a y here, so I'm going to treat that y as a constant. I'm going to treat that y as a constant, and I only have one variable, x. So let's think about how I would take the derivative here. I have y times this natural log function, but remember, we're not treating y as a function. We're treating y as a constant, meaning do I need to use product rule for this partial derivative? No, I don't need to use product rule. I can just keep the y there and focus on the derivative of this piece right here. Well, what's that derivative going to require? I have a function that's in terms of my variable, right? I do have a variable inside here. I have a function inside of a natural log function. So this is going to require chain rule. So I'm going to take the derivative of natural log, which is just 1 over my variable, but I'm going to keep the inside function the same. So 5x plus 2y. And then I'm going to multiply by the derivative of the inside function. So now if I focus on that inside function, what's my partial in terms of x? Well, derivative of 5x is just 5. The derivative of 2y doesn't depend on x. It's a constant. So that piece just goes to 0. And I'm left with just times 5. Put this all together and you get 5y over 5x plus 2y. And that's your partial in terms of x. Now the partial in terms of y gets a little bit more complicated. Why? Because this is now considered a function. And this natural log piece also contains a y, meaning I need to use product rule. This requires me to use product rule. So let me kind of break it down here. I've got my g function is y. My h function is this natural log of 5x plus 2y. I'll take the partial derivative of both, really just because I'm focusing on y, remember, I'm focusing on y here. So the derivative of g is just 1, and the derivative of h requires the chain rule because the inside function contains a y. So this requires chain rule, and I'm just going to get 1 over my inside function, 5x plus 2y, multiplied by the derivative of the inside. Well, the derivative of the inside contains 2 terms. One of them, 5x, though, 5x doesn't depend on y, so the derivative of that just becomes 0. And then my derivative of 2y is just 2. And so I'm going to have all of this multiplied by 2, meaning I can just change the numerator to 2. Okay? So now that I have the product rule, or now that I have each derivative of my 2 different pieces, then I can use the product rule to finish this derivative. I'll start with these 2 first. So I get y times 2 over 5x plus 2y, which just gives me 2y over 5x plus 2y. That's what I get when I multiply these 2 things. Plus, and then I'll multiply the second 2, and I get 1 times the natural log of 5x plus 2y. And that's my partial derivative in terms of y. Slightly more complicated because I had to use the product rule in order to evaluate it. Okay, the last question I want to go through from your homework is number 7. And this is where we get to talk about second order partial derivatives. And notice how it specifies we're going to find the 4, right? Remember, there's 4 different ways we could come up with a second order partial derivative. We're going to find all 4 of them. Well, in order to come up with my second order partial derivatives, I need my normal partial derivatives. So let's start with f sub x. Let's take the derivative of this function in terms of x. Well, there's 2 pieces, so I can focus on each term individually. If I take a look at that first term, I'm going to treat the 9 as a constant, and I'm going to treat the y to the 5th as a constant. So I'm going to keep both of those, and then I can focus on just the x to the 7th. What's the derivative of x to the 7th? I get 7x to the 6th. Okay, my second term, I'm going to do something similar. I'm going to keep the 3. I'm going to keep the y to the 6th because those are both constants. And then I take the derivative of x to the 8th, and that gives me 8x to the 7th. Well, let me clean this up just a little bit. And there's my partial derivative in terms of x. Okay, let's do this again, but for my partial derivative in terms of y. Since now I'm taking it in terms of y, I'm going to keep the constant, and I'm going to keep the x term because I'm treating the x term as constant now. And I'll just take the derivative of the y term. So y to the 5th, the derivative is 5y to the 4th. And then for my second terms, I'll do the same thing. I'll keep the 3, I'll keep the x to the 8th term because both of those are constant. And then I'll take the derivative of the y term. So I get 6y to the 5th. Clean that up, and you get 45x to the 7th, y to the 4th, plus 18x to the 8th, y to the 5th. Okay, so there's both of my partial derivatives. And remember, so from there, I can find 2 partial derivatives for each of those partial derivatives. So first, I could take the partial derivative of x of my partial derivative in terms of x. I could just take it in terms of x again. What is that going to give me? I'm going to keep the 63, keep my y terms because I'm treating the y terms as constant, and then I'll take the derivative of the x terms, 6x to the 5th. I'll do the same thing for the second term. Keep the 24, keep the y term because I'm treating it as constant, and take the derivative of the x term. And that gives me 378x to the 5th y to the 5th plus 168x to the 6th y to the 6th. Well, the other direction I can go from there is I can take that partial derivative in terms of x and then take the derivative in terms of y. So what'll that give me? I'm going to keep the 63. Since now I'm taking the derivative in terms of y, I'm going to keep the x term, treat that as constant, and then take the derivative of the y term. So 5 times y to the 4th. Do the same thing for the second term. And I get 315x to the 6th y to the 4th plus 144x to the 7th y to the 5th. Well now, so that takes care of 2 of my second order partial derivatives. For my other 2, I need to start with my partial in terms of y. So now I can take that partial in terms of y and then take the derivative in terms of x. Since I'm taking the derivative in terms of x, I'm going to keep the constant terms, which include any terms that are any terms with a y. Take the derivative of my x term, so 7x to the 6th. And I get 315x to the 6th times y to the 4th plus 144x to the 7th y to the 5th. Wait a second. Those are it's the exact same thing that I just barely got in my other second order partial derivative. So that's an important thing to realize with second order partial derivatives is it actually doesn't matter what order you do these partial derivatives in. Whether you do x first then y or y then x, you end up getting the same thing. Okay, but last, we need to take our partial derivative in terms of y and then take that derivative in terms of y again. So that means I'm going to keep the 45, keep the x to the 7th because those are constants, and then take the derivative of y to the 4th. So I get 4y cubed, and then same thing in the second piece. You get 180x to the 7th y cubed plus 90x to the 8th y to the 4th. And those are my 4 different second order derivatives. Okay, good luck with the rest of the homework. If you have any other questions, please reach out and let me know, and I'd be happy to help. But good luck, and I'll see you in the next video.